Let's talk about our handy dandy reference angles. So reference angles are the reason that I said you only really need to know the first quadrant of the unit circle. Every angle will have a reference angle that falls in the first quadrant. So the definition says that it has to be an acute angle, and that means that it is less than 90 degrees. So it'll also be a positive acute angle in the first quadrant. All right, so if you are given an angle, if your angle's in the first quadrant, you don't need a reference angle. The other cases would be that it's in quadrant 2, it's in quadrant 3, or it's in quadrant 4. If your angle is in quadrant 2, just for example, let's take this angle here, and that's our theta. So something like 135 degrees, just estimating something in the second quadrant. If you are looking for a reference angle, so the reference angle is an acute angle that's formed by the terminal side of your angle and the horizontal axis. So I like to think of it as the shortest way back to the x-axis. If you're in the second quadrant, the quickest way to the x-axis is to go down this way. So this is your reference angle. If you want like a step-by-step method of how to calculate the reference angle, if you're in quadrant 2, you are going to subtract your given angle from 180 or pi. So you'll do 100. So your reference angle, and they call the reference angle theta with like the apostrophe up there. It's read as theta prime, just to distinguish it from theta because they're not the same. But to get theta prime in this case, you would do 180 degrees minus theta, or pi if you're using radians minus theta. That'll give you the reference angle. If your angle's in quadrant 3, give just some angle that's in quadrant 3. So I'm rotating all the way down here. That's my theta. In this case, the shortest way to get back to the x-axis is to go this way here. Okay, so this green angle, so formed by the terminal side of the given angle and the horizontal axis, that's the reference angle. So to figure out how much that is, usually if it's in degrees especially, you can just count back to 180. But what you would be doing is you would be taking the angle and subtracting 180 if you're in quadrant 3. Taking angle and subtracting pi. That'll give you the reference angle. All right, so last case, we are in quadrant 4. So maybe we've got this angle here, a really big one, that's our theta. In fourth quadrant, the shortest way back to the x-axis is to come up here to 0 or 2 pi or 360. So the angle formed by the terminal side and the horizontal axis, that is our reference angle. If your angle is in quadrant 4, you will, to calculate the reference angle, have to subtract the given angle from 2 pi or 360. Okay, so let's try that out with some real angles. All right, in part A, our angle is 300 degrees, so I'm just gonna kind of sketch it so that I have an idea which quadrant that angle is in. So now this is 0, we're in degrees, so I'm gonna label in degrees. This is 90, that's 180. This is 270, so 300 must be in here somewhere. From 300 degrees, shortest distance back to the horizontal or the x-axis is this angle right here. So this angle is my reference angle. And if you like the step-by-step writing an equation, here you would take 360 and you would subtract our angle 300. I usually just think, well, how far do I have to go from 300 to get back to the x-axis? So how far do I have to go from 300 to 360? And that's 60 degrees. So the reference angle for 300 degrees is 60 degrees. You can double check yourself. Your reference angle should be a positive acute angle. So if you end up with something negative or you end up with something bigger than 90 degrees, then you may have subtracted the wrong thing. All right, let's take a look at B. B is a little tricky. Here, there's no degree symbol, so we are in radians. So we're looking for 2.3 radians. So this is 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi over 2. This is 2 pi. And because our angle is given to us as a decimal, it might be helpful to think of these as decimals. And we don't even need to know exactly, we can estimate pi. That pi is about 3.14. So pi over 2 is about half of that. And I can tell that 2.3 is in between those. If you're not sure, use your calculator. Make sure you know how to set it up so that it doesn't just give you pi back. It'll give you the decimal. So you can see exactly how much pi over 2 is, exactly how much pi is, and convince yourself that 2.3 is in between those. So 2.3 is in quadrant 2 somewhere. So our reference angle is this one right here. So we just got to figure out how much is this. So how far to go from 2.3 to 3.14, and let's be a little bit more exact. So this is a situation where the equation is handy because it's a little bit harder to count between the decimals. I mean, this one is not terrible. So how far do I have to go from 2.3 to 3.14? But it might just be easier to go and put that in a calculator. And we're going to subtract. So start with pi, subtract 2.3. And whatever's left over is the reference angle. And I'm going to go ahead and leave 2 numbers after the decimal point here. And I got 0.84 radians. Let's see, we're back in degrees, but this time our angle is negative. If you are comfortable graphing negative angle, we have a lot of practice with that in 1.1. So just go ahead and find out which quadrant that would fall into. If you are not so sure or a little bit uncomfortable with the negative angles, what you can do is find a coterminal angle and graph that one instead. So if you find a positive coterminal angle, you can graph that one instead. They have the same reference angle. So if I did that, I would be adding 360 degrees to negative 135, and I would get a positive 225, and I would use that angle. If that one is easier to graph, then graph that one. But either way, that's going to put us in the 3rd quadrant, and the shortest way back to the x-axis, this angle right here. So if I'm still in the negatives, this would be negative 180. And I would see how far from negative 1/3 to negative 180. But remember that you want your reference angle to be positive. So whatever you get, just make it positive for the reference angle. But if you did the coterminal angle thing and you're in positives, you don't have to worry about that. So this would be positive 180 times 270, 225. All right, so we're just looking for the difference between 180 and 225. So we could subtract 225 minus 180, or you could count, from 180 to 225. Looks like that's going to be 45 degrees. All right, so that's how you find a reference angle. The reference angle is useful to us because if we don't have access to a calculator or the unit circle, and we don't want to memorize the whole thing, we only memorize in the 1st quadrant. Every angle has a reference angle that's in the 1st quadrant. So if you can find its reference angle, the original angle and the reference angle will have the same sine, cosine, tangent, secant, cosecant, cotangent values, except for maybe the sign. Because remember, The reference angles are on quadrant 1, so they're always going to give you something positive when you take sine of a reference angle. You're going to get something positive. But you do have to consider the original angle in which quadrant it fell into. That's going to tell you whether your answer should be positive or negative. So let's see what all that is. By doing an example, let's use the reference angle for 4 pi over 3 to evaluate cosine of 4 pi over 3. All right, so let's find the reference angle. First, let's take a look where this angle is. We're in radians here. So now this is, I know pi right here is 3 pi over 3. So 4 pi over 3 is a little bit bigger than that. So somewhere in the third quadrant. And because the way that I wrote pi with the denominator 3, that made it a little bit easier to see what the reference angle is here. How far do I have to go from 4 pi over 3 to get back to 3 pi over 3? Well, just 1 pi over 3. That's the reference angle. So reference angle for 4 pi over 3 is pi over 3. So if I can find cosine of pi over 3, and I know whether cosine is positive or negative in the third quadrant, then I can figure out cosine of 4 pi over 3. So if you got this on a test and you don't have a calculator, you don't have a unit circle, I'm not going to leave it blank. We're going to figure it out by hand. This might be a handy time to draw your own unit circle, the first quadrant, or use the little table. And we want pi over 3. I usually just put all of them on there and keep it handy. So pi over 6, pi over 4, pi over 3, pi over 2. Remember, sign starts at 0 and goes up to 1. So we got 1/2 square root 2 over 2, square root 3 over 2. Square root of 4 over 2 is 1. And these do the opposite. All right. Now, I know the reference angle is pi over 3. I know cosine of pi over 3. Cosine of pi over 3 is 1/2. So cosine of 4 pi over 3 is 1/2. But is it positive or negative? Let's see. All students take calculus. In quadrant 3, cosine is negative. So cosine of 4 pi over 3 is the same as cosine of pi over 3. It's just negative. And I know cosine of pi over 3 is 1/2. So cosine of 4 pi over 3 is a negative 1/2. So let's do the same thing in part B. We got a negative angle, negative 210. Figure out where that is. I know it's somewhere in the second quadrant. This would be negative 180. So we're going to go further than that. But so that we don't have to fool with the negatives, let's find a coterminal angle for negative 210 by adding 360 degrees to it. That would give us 150 degrees, which is it. And that makes it a little bit easier, perhaps, to see that the reference angle here is just 30 degrees. To go from 150 to 180 is 30 degrees, the difference. So tangent of negative 210, negative 210 degrees. Let's see if it is positive or negative. In quadrant 2, only sine and its reciprocal are positive. So that means tangent is negative. So tangent of negative 210 is the same as negative tangent of the reference angle. And the reference angle is 30 degrees. All right, tangent of 30 degrees. We've got to figure out what that is. Well, tangent, we know from an identity, is sine over cosine. So this would be sine of 30 degrees over cosine of 30 degrees. And both of those will show up on your chart or in the first quadrant of the unit circle if you drew that. And that would give us 1/2 over square root 3 over 2. Sine of 30 degrees is 1/2. Cosine is square root 3 over 2. We'll just divide these. When we divide in our fractions, flip the second one and multiply. That gives us a negative 1 over the square root 3. And when we rationalize, we get square root 3 over 3, negative. So that is tangent of negative 210. All right, I'll let you try part C. A little hint there is that cosecant is not going to show up on your unit circle, but because you know it's the reciprocal of sine, it is 1 over sine If you can find sine of that reference angle, then you'll just use the reciprocal of that to get cosecant. So please let me know if you have questions about that one. Let the answer be made available to you by that is reference angles. And they are the reason that we only need to know the first quadrant. Every angle has a reference angle that falls in the first quadrant.